Hello everyone. So this is the video lesson 22, and in this video lesson we will discuss some tutorial problems again depending on the different derivations. Okay, so this is the question number 24. So that for the frequency less than or equal to 10 to power 9 Hz, the sample of silicon will act as a good conductor. Okay, so we know that the conductivity of a medium depends on the frequency in the case of electromagnetic field theory. Okay, so we will check the conductivity related issue of the silicon sample, and then after we have to find out the penetration depth, which is known as the skin depth of the sample at 10 to power 6 Hz, given that epsilon upon epsilon naught is equal to 12. Okay, here epsilon is the absolute permittivity, epsilon naught is the permittivity of the free space. This ratio is known as the relative permittivity or the dielectric constant, and this value is given as 12. Conductivity sigma, electrical conductivity, this is also known as the specific conductance, is equal to 200 ohm inverse per meter. Okay, so let's start with the first part of the question, that the sample is a good conductor at the frequency 10 to power 9 Hz. So we know that for the good conductor, the loss tangent tan delta is equal to sigma divided by omega epsilon must be very greater than 1. Okay, so we define the loss tangent. Okay, this is the ratio of the conduction current density to the displacement current density, and if this ratio, that means loss tangent, is very less than 1, then the medium is dielectric. If this ratio is very greater than 1, then the medium is conductor, and if this ratio is equal to 1, the medium is known as the quasi-conductor. Okay, so for good conductor, this value must be very greater than 1. Okay, so let's put the value. Okay, here we collect the data from the question. The frequency on which we have to check the conductivity is 10 to power 9 Hz. Epsilon naught is a constant. It is 8.86 cross 10 to the minus 12 farad per meter. Now we write the loss tangent equation, and this is the ratio of Jc over Jd, and this value comes to be sigma upon omega epsilon, and omega is equal to 2 pi f. F is the frequency, epsilon is equal to epsilon naught epsilon r, so we put different values. The calculation gives us 299.54. so this is very greater than 1. Okay, this is near about 300, very greater than 1. This implies that the sample of the silicon is a good conductor at 10 to power 9 Hz. Okay, so this is the answer. Now let's see the second part of the question. In the second part, we have to find out the penetration depth or the skin depth at the frequency 10 to power 6 Hz. Okay, so skin depth is given by 1 upon beta. Here beta is known as the phase constant. Okay, so we define the phase constant from the propagation constant. Okay, the propagation constant is a complex quantity. In the case of conductors, it is given by alpha plus I beta. Alpha is known as the attenuation constant, beta is known as the phase constant. Okay, so the delta, that's the skin depth, is 1 upon beta, and for good conductor beta is given by this equation. This implies skin depth is given by under root 2 upon omega mu sigma. So let's put the different value. Omega is equal to 2 pi f, mu is equal to mu naught mu r. Here mu r is equal to 1 because the value is not given in the question, and we consider the silicon as a non-magnetic substance. Okay, so let's take mu r is equal to 1 and frequency f is equal to 10 to power 6 Hz. So let's put the value, and we obtain the skin depth 0.0356 meters. Okay, so this is the answer. Let's take another question. Question number 25. The question is that the ocean water can be assumed to be a non-magnetic dielectric. Okay, non-magnetic means mu r, relative permeability, is equal to 1. This is to be a non-magnetic dielectric with k is known as the dielectric constant, is equal to epsilon upon epsilon naught is equal to 80. This is the ratio which is known as the dielectric constant, comma sigma means conductivity is equal to 4.3 ohm inverse per meter. Now the question is, find the frequency at which the penetration will be 10 centimeter. Okay, and second question is, so that at frequency less than 10 to power 8 hertz the ocean water can be considered as the good conductor. Okay, so let's solve the question. So first of all, we collect the data from the question. The dielectric constant k is equal to epsilon r. Okay, so relative permittivity and dielectric constant, they are the both are the same, and they are defined as the absolute permittivity to the permittivity in free space is equal to 80, and the conductivity sigma is equal to 4.3 ohm inverse per meter, and epsilon naught is here. So first of all, let's calculate the frequency for which delta is equal to 10 centimeter. So let's apply the formula for the skin depth for the good conductor, and we take the different values and we place the values in this equation, and finally we obtain the frequency 5.896 megahertz at which delta is equal to 10 centimeter. Okay, now the second part of the question, we have to prove that at the frequency less than 10 to power 8 hertz the ocean water will act as a good conductor. Okay, so for this let's check the loss tangent value. Okay, and this value comes to be 9.66, and which is greater than 1, and therefore the ocean water at the frequency less than 10 to power 8 hertz may act as the good conductor. So this is the answer. Let's see another problem. Question number 26. An aluminum sheet is exposed to the laser radiation of wavelength lambda is equal to 6328 angstrom. Calculate the penetration depth if mu is equal to mu naught. Okay, and sigma is equal to 3.5 into 10 to power 7 Simon per meter. So you can see here that mu is equal to mu naught. This implies that mu r is equal to 1. Okay, mu r is equal to 1 means the specimen is considered as a non-magnetic substance. Okay, so here mu is equal to mu naught, this implies mu r is equal to 1. Also sigma is equal to 3.5 cross 10 power 7 Simon per meter. So in previous two numerical question we use the unit of conductivity as the ohm inverse per meter, but here we use the unit Simon per meter. So both are the same units. Here 1 Simons per meter is equal to 1 Mohoge per meter, or 1 ohm inverse per meter, or 1 upon ohm meter. Okay, so all are the SI units of electrical conductivity, and electrical conductivity is also known as the specific conductance. Now let's see the solution. Here lambda is given 6328 angstrom, but in the formula of the penetration depth we need the frequency. So first of all we change the wavelength in terms of the frequency by using the equation c is equal to nu lambda. So this is the equation in which the medium is free space. Okay, so let's find the frequency which is about 4.7408 into 10 to power 14, and then after we place the value in the equation of the penetration depth, and here omega is equal to 2 pi f, mu is equal to mu naught mu r. Okay, and then after we place the value of sigma and we calculate the equation, and it comes to 0.3909 angstrom. Okay, thank you.